Have you ever wondered if we are alone in the universe? Are there other intelligent civilizations out there? These are questions that have puzzled scientists and astronomers for decades. In this video, we will explore the Drake equation, a formula used to estimate the number of intelligent civilizations in the universe. The Drake equation was developed by astronomer Frank Drake in 1961. It is a mathematical equation that takes into account various factors that are necessary for the existence of intelligent life. The equation is as follows. N equals R asterisk 6 FBX NEX FL XY XFC XL, where N is the number of civilizations in our galaxy with which communication might be possible. R asterisk is the average rate of star formation per year in our galaxy. FP is the fraction of those stars that have planets. N is the average number of planets that can potentially support life per star that has planet. FL is the fraction of planets that could support life that actually develop life. Phi is the fraction of planets with life that develop intelligent life. SE is the fraction of civilizations that develop a technology that releases detectable signs of their existence into space, and L is the length of time such civilizations release detectable signals into space. In this video, we will break down each factor of the Drake equation and explore how it contributes to estimating the number of intelligent civilizations in the universe. The first factor of the Drake equation is R asterisk, which represents the average rate of star formation per year in our galaxy. This factor is important because stars are the building blocks of planetary systems, and planets are necessary for the existence of life. Scientists estimate that there are between 100 and 400 billion stars in our Milky Way galaxy alone. However, not all stars are created equal. Some stars are much larger and hotter than our Sun, while others are smaller and cooler. The rate of star formation also varies depending on the region of the galaxy. Based on current estimates, the average rate of star formation in our galaxy is around 7 new stars per year. This means that over the course of 1 billion years, there would be around 7 billion new stars formed in our galaxy. While this number may seem high, it is important to remember that not all stars have planets, and not all planets are capable of supporting life. This is where the other factors of the Drake equation come into play. In the next segment, we will explore the second factor of the Drake equation, FP, which represents the fraction of stars that have planets. The second factor of the Drake equation is FP, which represents the fraction of stars that have planets. This factor is important because planets are necessary for the existence of life as we know it. Thanks to recent advances in technology, astronomers have discovered thousands of exoplanets, or planets outside of our solar system. These discoveries have led scientists to believe that planets are common in our galaxy. Based on current estimates, it is believed that around 1 in 5 stars have at least one planet in their habitable zone, which is the region around a star where conditions are just right for liquid water to exist on the surface of a planet. This means that out of the 7 billion new stars formed in our galaxy over the course of 1 billion years, around 1.4 billion of them would have at least one planet in their habitable zone. However, not all of these planets are capable of supporting life. In the next segment, we will explore the third factor of the Drake equation, Ni, which represents the average number of planets that can potentially support life per star that has planets. The third factor of the Drake equation is Ni, which represents the average number of planets that can potentially support life per star that has planets. This factor is important because not all planets in a star's habitable zone are capable of supporting life. Scientists believe that there are certain conditions that a planet must meet in order to support life. These conditions include having a stable climate, a protective atmosphere, and a source of liquid water. Based on current estimates, it is believed that around 1 in 5 planets in a star's habitable zone are capable of supporting life. This means that out of the 1.4 billion stars with at least one planet in their habitable zone, around 280 million of them would have at least one planet capable of supporting life. However, just because a planet is capable of supporting life does not mean that life actually exists on that planet. In the next segment, we will explore the fourth factor of the Drake equation, FL, which represents the fraction of planets that could support life that actually develop life. The fourth factor of the Drake equation is FL, which represents the fraction of planets that could support life that actually develop life. This factor is important because not all planets capable of supporting life actually have life on them. Scientists are still trying to understand how life began on Earth, but they believe that certain conditions, such as the presence of liquid water and organic molecules, were necessary for life to develop. Based on current estimates, it is believed that around 1 in 10 planets capable of supporting life actually develop life. This means that out of the 280 million planets capable of supporting life, around 28 million of them would actually have life on them. However, not all life is intelligent. In fact, the vast majority of life on Earth is not intelligent. In the next segment, we will explore the fifth factor of the Drake equation, Phi, which represents the fraction of planets with life that develop intelligent life.